All right, today's topic is another review situation for us. We're going to graph linear inequalities, which is something you've done before, hopefully. So if I'm going to graph the inequality y is greater than 2x minus 7, where I start is, number one, by thinking of it more as an equation to get two of my points to graph. Okay, so when I look at that, I see that it's in slope-intercept form, and my y-intercept is negative 7. My slope is 2 over 1, so up 2 over 1 to get my 2 points that I need to graph my line. Where we may differ a little bit is in terms of what type of line we're going to use. We have two choices. Either we can have a solid line or we could have a dashed line. If we have a solid line, we want to do that because my inequality is a greater than or equal to or a less than or equal to. Because the points on that line are also solutions to that inequality. They're the solutions that make the two sides equal. A dashed line is more like a boundary. And I compare it again to the idea of a fence between my yard and my neighbor's yard. Okay. On the fence, we're not in the yard. It's not a solution. But as soon as we fall off one side or the other, now it's a solution on one side. Okay, so we use the dashed line without the equal sign. We need that boundary. So in this case, because I don't have the equal sign, I'll be using the dashed line. And that's my boundary. So either on side number 1 or on side number 2, I'm going to find all my solutions for this inequality. Okay. Now, how we deal with that, again, is we're going to shade one side or the other. There's two ways we can deal with that. One, I could pick a point. And if possible, I like to use the point 0, 0. Now, that point cannot be on my line that I drew. Okay, so in this case, 0, 0 is fine. The reason I like 0, 0 again is because the properties of 0. Multiplication by 0, okay, you get 0. If you add 0 to anything or something to 0, you get that thing right back. And so when I plug it in up here, I get 0 greater than, the 2 times 0 goes to 0, and I'm left with negative 7. Okay. Now, because I get a situation that's true, 0 is greater than negative 7, that's telling me that that point 0, 0 is a solution to that inequality. Okay. As is every other point on side number 1. Okay. And so that's the side that, in this case, I would shade. It contains all my solutions. Okay. Had I gotten a situation where it was false, where it wasn't true, then that would be a non-solution. So then we would look at the other side to be our solutions, because one side's going to have my solutions, the other side will not. Okay. Now another easy method, and I like to use this when it's in slope-intercept form, because what we have is my y is all by itself. And so what it's asking me up here is I want y values that are greater than the 2x minus 7. So when I take an x value and plug it in, my input, I get a y out. But what I want is when I input that x value, I want y is bigger than one that comes out. So what we're saying here is when I input 0, I get negative 7. I want y values that are bigger than negative 7, negative 5, negative 3, 2, and all those. So what we can look at is when it says greater than, we can shade above. Generally, I only recommend this if it's in slope-intercept form. Second situation. Now my equation is in standard form, my inequality, I should say, but it's the same idea. I'm still going to graph it as if it were an equation. So in this case, we're going to use my intercepts method. So when I let x equal 0, okay, again, that's when I'm finding my y-intercept. Okay, that piece, 2x goes to 0, divide both sides by negative 6, and y becomes negative 2. When I let y equal 0, okay, again, that's the 0 for my function. Okay, that's the value for x that makes my function value be 0, and so again, that's my x-intercept. And so in this case, we'll divide both sides by 2, and x ends up being 6. So there's my 2 points that I can plot. And we always need 2 points to plot. Okay. So we move on to our line. In this case, I have the equal sign. Therefore, it will be a solid line. The points on that line, when I input them in, the ordered pairs, they will equal 12. And that's why they're solutions. That's why we want to include them. To figure out where we shade, I'm going to pick a point. Again, 0, 0 is not on the line, so I'm able to do that. And here's the great thing about using 0, 0 in standard form is that whole left side, 2 times 0 is 0, 6 times 0 is 0, 0 minus 0 ends up giving me 0. That whole side containing my variables goes to 0. This time I get a false expression. Okay, 0 is not greater than or equal to 12. So that means this point is not a solution, and any points on this side of that fence are not solutions, meaning the opposite side are my solutions. And again, when we do this, we want to shade the side that contains my solutions. Okay. Now, another thing I could do in this case is I could also pull a point off of my graph where I believe I have a solution. And I could go back and plug that into my original inequality and just make sure that it is a solution. Okay, so when we go through and simplify, we get 20 plus 60, or we get 80, which is greater than 2. So it truly is a solution. All right, so the next piece we have to talk about are compound inequalities. Compound simply means what we're talking about is more than one. Okay, in most cases, we're going to be dealing with 2. If you remember, compound inequalities, what we can see sometimes is an and, like we have here. In the other cases, we see an or. Okay, when we talk about ors, again, with compound inequalities, if it works for one of my situations, it's going to be a solution overall. With my ands, again, it has to work for every one of them. Now, the big piece here that you have to keep in mind is we need to keep that x plus 2y together. Okay, because what we're truly talking about is my first piece is less than or equal to my second piece is less than or equal to my third piece. Okay, that is all one piece together, so it has to stay there. So because we're dealing with 2 inequalities, what we want to do is break them into those 2 pieces separately. Okay, so one of my inequalities is -2 less than or equal to x plus 2y. Now, like I said, could be an and, could be an or. How we know the difference again is if it's an or, you will see the words or. Okay, if not, it's got to be an and. So in this case, what we have is an and situation. So when I'm looking for solutions here, one, they're going to have to work for the -2 less than or equal to x plus 2y. So those ordered pairs may be, but then at the same time, they also have to work in the second inequality, x plus 2y less than or equal to 4. Okay. So what we'll do is we're going to graph both of these individually, okay, and look for those points that work for both inequalities. So again, because it's in standard form, and I'm going to quickly go through this, we're going to use intercepts method again. So when I let x be 0, I'm going to divide both sides by 2 and get -1. When I let y be 0, I'm going to be left with x equals -2. So 0, -1, -2, 0. Equal sign, so we're going with a solid line. Okay. We still want to think about shading. Okay. So if I plug in 0, 0 in this case, again, that whole side's going to go 0. Be careful, that says -2 less than or equal to 0. It is true. Don't get crazy and just shade really hard in there so you can't see what's going on. What I suggest is simply a couple of arrows pointing in the direction we want to go. Another option would be to maybe use like a highlighter. Okay. And that seems to work well for some people. Okay. Go graph the second one. Again, it's in standard form. So I'm going to go with my intercepts. X equals 0, y is going to be 2, y equals 0, x is going to be 4. Okay, so I got a point here at 0, 2, and I got a point here at 4, 0. Again, the equal sign is there, so what we'll have is a solid line again. If I check my regions again, if I check 0, 0, I'm going to get 0 less than or equal to 4, which is true, so I'm going to shade on this side. If I went with the highlighter idea again, it's going to be down here. Now, my final region, okay, the region where I have my solutions is where both inequalities have been graphed. And as you can see, that's this chunk right here in the middle. Okay. Now, I didn't do a great job of graphing my lines. Hopefully you're thinking as you were going along that, hey, these two lines should be parallel. Okay, because if you remember the idea, slope in standard form is the opposite of A over B. We go over here, okay, so they are going to be parallel. You have to make sure when you graph these out that whoever's looking at them definitely knows where your solutions lie. Okay, so if I use that highlighter, you know, I might be able to see it, but another thing you can always do is say with an arrow, this region contains my solutions to the inequality. All right, good luck with that one.